Okay, problem number 27. A circle is graphed on a coordinate grid and then reflected across the y-axis. If the center of the original circle is located at x, y, which of the ordered pair represents the center of the new circle after the transformation? Listen, this is an awful figure to use because a circle is always, a circle has the same radius, so quite frankly, this is an awful, awful figure to use. But listen, we're just talking about the rules of reflection, and we're not really talking about actually reflecting this. So if you think about it in terms of the rules of reflection, then we're okay. So in terms of just talking about the rules of reflection, we want to think about how the values, how x and the value of x and the value of y are changing when we reflect it across whichever axis we're looking at. So if we're looking at, let's say, this is y. Let me walk it. And then this is x. All right. Now, in order, let's say I take my figure, and let's say my figure is here. Okay? And I'm going to reflect this figure, and I'm going to reflect it across the x-axis. Okay? So now I reflect it across the x-axis. So whatever the value here was here, okay, now let's look in terms of, and whatever value was there is now going to be on, not on that side, it's actually going to be here. So whatever was here and we reflected across is now going to be there, because we're talking about like in terms of picturing it. Now, whatever the x value was, if I'm reflecting across the x-axis, whatever the x value was, it's going to be what? The same. Because if we were to draw a line, I'm going to draw the line that our x value did not change, but our y value did. So in terms of reflecting it across the x-axis, now my x value is going to be negative x, and my y value, or not, sorry, said that wrong. My x value is going to stay the same, but my y value is going to change. Now let's think about that in terms of reflection. So we can remember this, that if I'm reflecting it across the x-axis, the x value does not change. So it's the opposite value that's going to change. But we're not reflecting it across the x-axis. We're reflecting it across the y-axis. So now let's erase this. I'm going to erase that figure. And erase that figure. All right. So now I'm going to draw my figure again. And let's do a different color. So we're reflecting across the y-axis. Now let's look. If I were to draw a line here, in terms of horizontal, I would look at a horizontal line. Horizontal line, all our y values are going to stay the same. So in terms of talking about what changes, now, so my changes, when I rewrite this, I'm going to keep my y value because it didn't change. And since I'm reflecting it, all my values to the right of my origin's there. Look, it looks like a little face. Looks like something I could draw like little whiskers and be like a kitty cat. See? I brought cats into my mathematics. Anyways, sorry, I'm on vacation here. Leave me alone. All right, now, talking about in terms of, let me go back, erase my whiskers so that we can talk about the actual value here. Now, all my values to the right of my origin are positive, but now we went to the left of the origin, so all my x values, and it's my x values that are changing, not my y values. My y values all stay the same, so now my x values are going to be negative. So, in terms of my new transformation, what pair, ordered pair, if my original pair is xy, so my pre-image is xy, my image is going to be negative x, comma y. So A won't work, B won't work. B is if we reflected across x-axis. But we want to reflect it across the y-axis. And D would be a rotation. And we'll we may end up having some rotation questions on here. We'll see. And then I'll go over number 16 and or number 28 in the next video.